Hey, what's going on, guys? Let's do this problem right here. The question is asking to evaluate these integrals. Let's begin with this one right here. So first of all, if you look at this one, the derivative is on top. Derivative of sin x is on top. So we can do the u substitution right here. Let's pick up u as sin x. So if I pick u for sin x, du is going to be cos x dx, right? Cos x dx. Now I can write everything in terms of u. So let's write everything in terms of u. This is going to be, in top we are going to have du, and in the bottom we are going to have u 1 plus u, right? And here we can do the partial fraction decomposition. So partial fraction. So if I do that, we take this part separately, 1 over u times 1 plus u, and the other side we are going to have a over u plus b over 1 plus u. And to get rid of these denominators, we multiply both sides by this denominator right here. So that is going to be u times 1 plus u in this side, and here also you multiply by u times 1 plus u. So if you do that, we will get 1 right in this side, and the other side we will have a times 1 plus u plus b times u, because for this one u cancels and we will be having 1 plus u. For b we will be, this will 1 plus u will cancel and u will remain, right? So let's simplify this one furthermore. So 1 is equal to a plus au plus bu, right? And here if you look at this this one, we have only one constant right here. So this is u power 1. So constant is 1 is equal to a. U power 1, we are equating the coefficients. So let's write this one. Equating coefficients. So equating coefficients, we have a is equal to 1, but a plus b is equal to 0, because other side we don't have any u power, so u power 1, so it's equal to 0. Since we know that a is equal to 1, b is definitely going to be negative 1, because when we add them together, this is equal to 0. So b is equal to negative 1. So we know that a and we found out a and b. So let's plug this one into this form for equation right here. So this one is same as integral of 1 over u plus 1 over minus 1 over 1 plus u. That's what partial fraction do, like it bring this pattern into fraction form. So this is 1 over u also altogether du, right? We can write this one as, let's continue this right here, integral of 1 over u minus 1 over 1 plus u du, and now this is easy to integrate. This is going to be ln u minus ln 1 plus u. Now all you have to do is simply substitute the u value, that is sin x. So ln, final answer is going to be ln sin x minus ln 1 plus sin x plus constant, and that is our final answer. So let's do this other side. Let's go to the other side and solve this problem right here. So for this one, what we can do, since we have 1 on top and these things are right here, what we can do, we can multiply everything by e power x to bring the e power x on the top. So let's multiply everything by e power x and see what we get. So if I multiply everything by e power x, in the top we are going to have e power x. In the bottom we have e power x, e power minus x. It's going to be just 2 right here. Just 2 plus e power x e power x square basically if I multiply, then dx. So from this one what we can do, so let's do the u substitution and see what we get. U is equal to e power x over root 2. This is not like you can't see it directly, but it takes time to understand, but this one works. If you take e power x over root 2 and therefore du is going to be e power x over root 2 dx. So now we are trying to substitute for e power x, right? So we can bring the root 2 to the other side. So root 2 u is equal to root 2 u is equal to e power x. In here we are trying to substitute for e power x dx. So du root 2 is equal to e power x dx. Now let's write everything in terms of u. So here if you write everything in terms of u, the first one e power x dx, we can replace that one by du root 2. So root 2 du. In the denominator we have 2 plus, instead of e power x we replace with root 2u. So root 2u square, right? So let's look at this. So root 2 du, 2 plus 2u square. So this is what we got, and 2 is same as 2 is equal to root 2 times root 2, right? So let's see what we can do with that information. So here we have 2 plus 2u square. So what I can do, if I separate this one into root 2 times root 2, one of the root 2 will cancel. So let's do that. So integral root 2 du over, I can write 2 as root 2 times root 2 and other 2u square as root 2 times root 2 u square. If I cancel this one, I can cancel one of this in each. So we are left with integral of du over root 2 plus root 2 u square. Now I can take the 1 over root 2 to the other side. 1 over root 2, since it's a constant, I can take it. So this is going to be du over 1 plus u square, and this is same as 1 over root 2 integral 1 over 1 plus u square. And if you remember that derivative of tan inverse, so when we have the tan function, I write this one right here. So tan inverse x is equal to 1 over 1 plus x square, right? This is the derivative of tan inverse. Derivative. So here we have that pattern right here. So if we integrate this one, we can get the tan inverse back. So let's integrate. So we can directly integrate this one. 1 over root 2 tan inverse u. Tan inverse u plus constant. Now we can replace this u with this value right here, e power x over root 2. So 1 over root 2 times tan inverse e power x over root 2 plus constant is our final answer. And that's how we do these problems. I hope you guys like this video. See you next time.